Hello, good morning, guys. Very good morning to you all. Okay, today after last week, we have learned something about the solar system, the Earth, about the asteroid. If you still remember, okay. First of all, you can clear out your table from all the other things. What I need is only three. Okay, three books that you need is the textbook, which is the learner's book for science, the workbook, and also your exercise book, right? But I think your workbook is still with me. I will give out this week. So take out your learner's book. Okay, this is your learner's book, right? What we have learned last week is this our solar system. Which is 5.4, subtopic 5.4, light in the solar system, which is we have learned about the orbits. What is the orbits? We have learned that our solar system, the eight planet, which is from uh my formula is if you still remember, okay, still remember this: Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune, right? All the eight planets. And beside planets, we got also the asteroids. Let's see here, page. Please open page 111. Okay. Asteroids, moons. So asteroids and moons is not a planet. Okay. So in the solar system, only got sun, one star, which is the sun, eight planets, and some celestial bodies like as asteroids, moons, and also comets. Okay, but for today, we're gonna go into the new subtopic, which is 5.5, page 113, with day and night. Okay, so are you ready? Okay, day and night will cover until page about, yeah, from 113 until 115. Okay, so let's see here, 113 here, the model of the Earth. Can you see the globe now here? Okay, this is the globe. Um, a lot of things you need to have your imagination running. So because we cannot see the Earth right now, you can only see what in front of you. But in our next class, I will bring the globe. So to show to you, which is I think the globe has light. So we will try to do this thing like a scientist later. Okay. So for today, you need to know the theory of what are these things. So okay, this is the globe. You see here the Earth globe, and maybe you will ask why is the earth tilting a bit? Okay. So the earth are tilting some at some degrees. Okay. It's not straight up, straight for upward, right? That is one thing. Okay. Can you see the orange wording here? So anti-clockwise, axis, globe, spin, and tilted. So this is the words that in this subtopic that this is the important words. Okay. So if you don't understand what is these words, please let me know. Take a note because this is how you understand the subtopic, the day and night. Okay, you need to know about all this. So first of all, let's see here. The Earth, a model of the Earth. So this is the globe. Okay, I said it many times. This is the globe, and you can spin the globe as the Earth can spin also. So there's a um two type of movement for Earth. One is spinning on its axis. So what is axis? Okay. I'll show you later. So one is spinning on its axis and one is the revolution, meaning the Earth traveling in the orbit around the sun. Okay, that is revolution, which is we are not talking about that today, but for today we are talking about the rotation of the Earth, or we can say also spin, the spinning. Okay, okay, you see here. I'll show you. So let's say this is the Earth, and let's say this is and the which is maybe initially you will thought you will see like this, but actually it is not. The axis of Earth straight up like this. It it is still a bit like this. Okay, 1 degrees, 23 point. Okay, how do you see it? Axis is like this. Sorry, this is line up. Okay, so from here to here is 23.5 degrees. So, so this is the axis. And the Earth will not like this, not like this, but like this. So always remember the Earth will travel in orbit in anti-clockwise. And also when Earth spin in its axis, it also spins in anti-clockwise. Okay, let's look at the textbook. So, um, yeah, and yeah, I just said about it. Anti-clockwise. Always remember, always remember this anti-clockwise. Not this one. Yes, for this one. Right? Yeah. Oh, I'll show you. If you at home, maybe you can Google also. Um, tilt angle. See here, Earth tilt angle about 23.5 degrees. But this angle can like changing for thousands of years. But that is a different story. Okay. So for now, you just need to know that Earth is tilting a bit about 23.5 degrees. Right? Okay. And the Earth's spin in its axis takes 24 hours. That is a 1 day. That's why we are talking about day and night here, right? So on, let's see one video. Let's watch one video. I'll show you, and maybe you can come up with some understanding here. All right. This is the Earth rotation and revolution. So, what is rotation and revolution? Like I said just now, spinning on its axis is the rotation, and revolution is the Earth traveling in the orbit. All right.
You've seen the sunset, right? And if you get up early enough, maybe you've seen it rise too. But have you ever wondered, if the sun rises every day and sets every night, where does it go when we can't see it? Well, nowhere. It's actually us that goes somewhere, because we're on the Earth and our planet is always turning or spinning on its axis. Imagine a line passing through the center of the Earth that goes both through the North Pole and the South Pole. We call that invisible line the axis. Earth spins around on this axis like a top. This spinning movement is called the Earth's rotation, and the Earth's rotation is what gives us day and night. Every day, all year. If you're on the side of the Earth that's facing away from the sun as the Earth is spinning, it's night. If you're on the side facing the sun, it's, you guessed it, day. Now, hold on tight, because the Earth is actually moving in more ways than one. At the same time that the Earth spins on its axis, it also orbits or revolves around the sun. This movement is called its revolution. One full orbit all the way around the sun is one revolution, and the Earth takes 365 days, or 1 year, to complete a revolution. So have you got all of this so far? The Earth is rotating on its axis, creating day and night, and at the same time, it's revolving all the way around the sun. Now here's the thing. As the Earth is both rotating and revolving, it's not sitting straight up and down. Its axis is actually tilted, just a little. It's not all that much, but this tilt causes one part of the Earth to lean towards the sun, while another part of it is leaning away. This means that different parts of our planet's surface gets different amounts of sunlight and heat. So, why am I telling you all of this? Well, as the Earth travels around the sun, it creates a pattern throughout the year. This pattern happens over and over again, and I'm sure you've noticed it. At certain times of the year, you see the northern hemisphere leans towards the sun, and the southern hemisphere leans away. And at other times, the southern hemisphere leans towards the sun, and the northern hemisphere leans away. That pattern, my friend, is what makes seasons. When the part of the world that you're living in is leaning towards the sun, it's warm and the days are long. Summer. When you're on the part that's leaning away from the sun, it's cold and the days are short. Winter. In between, it's spring or autumn. If the Earth weren't tilted, we would have the same season all year long. So, revolution, rotation, orbit. Is your head spinning? Let's do a demonstration to shed a little light on these concepts. Okay, you're gonna need a globe and a table lamp without a shade, plus a table to put them both on. Put the lamp in the center of the table and turn it on. Put the globe on one side of the table. Now hit the lights. The globe is Earth. Makes sense, right? The lamp at the center of the table is the sun at the center of the solar system. Now slowly spin the globe. As the Earth rotates, the sun lights up one side of the planet better than the other. It's day where the light is shining more brightly on the globe and night where it's not. Now let's see what the Earth's revolution around the sun looks like. Give the globe a few spins with one hand while slowly pushing the globe in a circle around the sun, or the lamp with your other hand. So, do you notice how the Earth keeps rotating as it revolves around the sun? If this were the real sun and Earth, by the time you get back to where you started, the globe would have completed 365 rotations or days, and that's another year gone by. So, what does all this show us? It shows that what looks to us to be the motion of the sun in the sky is really caused by the motion of the Earth. So now you know, when you look up and see the sun setting or rising, it's not going around us. It's sitting pretty much at the center of the solar system, while we and the 7 other planets go around it. That sun, always gotta be the center of attention.
Okay, now have you seen that? Let's go back here. Okay. So let's pick a new Earth. This is our new Earth. Don't look here. Alright? This is about this. Um, and this is the northern and this is southern hemisphere. Right? This is the south pole and the north pole. Okay. Now this is our new Earth. And this is right. This is make sure you know right. And what are the things are like tilted. So this is how tilted. This is the okay. So this is the axis and the earth spin. And also what gives you the day and night is because the earth spin. So what gives you day and night is because the earth spin. When the earth spin, you will see a day and night, which is where we are living right now is on Earth, but like here, I put an X here. This is where we are. So this is in our country, which is Malaysia. Let's zoom in a bit. Alright. When we are here, what we experience is is about 12 hours of day and hours of night. 12 hours of night and 12 hours of day. So when we start our day is between the dusk until dawn. Right. So day is between 7, yeah, between 7 a.m. to 7 p.m. And about night, 7 p.m. until 7 a.m. Yeah, so day and night, every day until next year. So if let's say you will experience 365 days, so what happened? Meaning like the Earth has um have complete one revolution, which is traveling in the orbit around the sun. So, alright, but always remember anti-clockwise, okay? Not clockwise. All the planets spin direction, and also revolution direction, meaning like traveling around the orbit, all is in a anti-clockwise direction. So, oh, I got another video for you, which is just now this one, and this is the next one.
SK2、まるで引力のように込まれていく。ピテラ。50種類以上の成分。この夏、毛穴の気にならない透明感のあるクリアな素肌へ。SK2。SK2、まるで引力のように素肌に吸い込まれていく。ピテラ。50種類以上の成分。この夏、毛穴の気にならない透明感のあるクリアな素肌へ。SK2。
What causes the repeating pattern of day and night? In space, the Earth moves in different ways. One way the Earth moves is by spinning on its axis. An axis is an imaginary line that runs through the Earth's center. This spinning movement on its axis is called a rotation. As it rotates, part of the Earth is facing the Sun. This part of the Earth is lit up and experiences daytime. At the same time, the opposite side of the Earth is facing away from the Sun. This part of the Earth is in darkness and it is nighttime. It takes the Earth 24 hours to complete one rotation. The repeating rotation of the Earth is why we experience the daily pattern of day and night. Here's a cool fact. The planets in the solar system rotate about their axis at different speeds. This means the length of a day on each planet is different. One day on Jupiter takes just 10 Earth hours. One day on Venus takes 243 Earth days. I think I'll call it a day now. See you later.
Alright, see that? So let's open the next page is 114. So now you can see that the second paragraph. Imagine driving very fast. Imagine that maybe your father or your mother traveling very fast, but you are actually traveling much faster on Earth. I mean, the Earth are traveling the Earth are spinning much faster than cars, alright? So how fast is the Earth spins is I think I told you guys right before this. You still remember what about this? 1,600 kilometer per hour. The the speed of the speed of the Earth at this. Let- Let's look at. You can Google also. Speed. There. You see, okay, 1,670 kilometer per hour. I think in the book just say that which seems fast, but Earth is spinning on its axis at least 10 times faster than this, right? But if we put the real number, this is it, right? About this speed. Okay, so you all okay for now? So what today what lesson for today is firstly, you see here, don't look here, right? First of all, Earth has axis like this. So in the book also doesn't mention about the degrees, but this is the extra information, right? 23.5 degrees. So how how lean the axis? 23.5 degrees from the center from the upright line here. Right? So the how about the Earth direction, the spinning direction? So the spinning direction is this one, anti-clockwise, not clockwise, right? Not clockwise, not clockwise, anti-clockwise. So this is the first thing, and anti-clockwise direction. Then we go to here. This is also extra. So the Earth, like the globe here, you see. Day and night, but not always like this. This is we are in Malaysia, alright? Let's say different story, but still you will experience day and night. But the timing will be because now the day is right now 7 in the morning until 7 p.m. For our night time is 7 p.m. until 7 a.m. This equivalent to 12 hours for day and 12 hours for night. Like I said, it's a different story. Okay. All right. So that's all I think. For your understanding, if you don't understand, you can ask me when I got back. So if you still got time left, because we have learned this in our previous class last week. So please do the workbook. Please open your workbook, okay? Uh, please open your workbook and do the page from, yeah, we did this together, page 70. I'm gonna wait you for a while. Please open your workbook, alright? Page 71. You can start from page 71 until page 73. Alright? 71 until 73. You don't have to do this yet. Oh, sorry. 71 until 74. 71 until 74. So you don't have to do this yet. Page 75. This is in our current topic. Alright. So don't have to do this. Just do the previous subtopic, which is 71 until 74. Alright, that's all. Thank you so much. And see you. Bye.